Hello, everyone. Welcome. Welcome to the Intrepid Sea, Air, and Space Museum. My name is Anne Schruth. I'm the manager of public programs here at the museum, and it is my great pleasure to welcome you here today. And I'd also like to thank you so much for joining us for this very special and exciting discussion about the new book, Chasing New Horizons, Inside the Epic First Mission to Pluto. We are so excited to welcome back Alan Stern and with him David Grinspoon to discuss this captivating and inspiring story from their two unique perspectives. It also feels fitting that this event should take place here at the Intrepid Museum, since 3 years ago we were fortunate enough to host Dr. Stern as he presented some of the first images of Pluto in our annual Space and Science Festival here at the museum. Before they get started, I'd like to share just a few details from their very impressive resumes. Dr. Alan Stern is the Principal Investigator of New Horizons, as well as a planetary scientist, space program executive, aerospace consultant, and author. He is the recipient of numerous awards, including the 2016 Carl Sagan Memorial Award of the American Astronautical Society, and has twice been named to the Time 100. Dr. David Grinspoon is an astrobiologist, award-winning science communicator, and prize-winning author. In 2013, he was appointed to the inaugural chair of astrobiology at the Library of Congress. He's a frequent advisor to NASA on space exploration strategy, and his writing has appeared in the New York Times, Slate, Scientific American, and the Los Angeles Times, just to name a few. So, with that, I would like to invite you and join me in welcoming to the stage Dr. David Grinspoon.
Thanks. Thank you so much, and thank you for coming out. I'm David. Alan is over here. I'm going to talk to you for a few minutes, and then Alan will talk to you for a few minutes, and then we'll both get up here and discuss with you. This is so exciting for us to be launching this book finally after a 3-year intense process of us working on it together, which followed a quarter-century intense process of Alan and many colleagues living out this story that we're going to introduce you to. So, Chasing New Horizons is the story of a group of human beings who created a very small and very powerful ship that went farther than any other ship in the history of human exploration. And I was thinking about that while we're gathered here together on this very large ship that we're going to be telling you a story about, a tiny but powerful underdog ship. I love this story because it's in many ways emblematic of modern space exploration, and there are aspects of it that nobody knows. You all know, I think, probably, that we made it to Pluto a few years ago, and there's drama and suspense in this story. You know, will they get to Pluto against all odds? And yet, on the cover of the book, you can see a beautiful photograph of Pluto taken when the New Horizons spacecraft got to Pluto. So we're not hiding the fact that you sort of know how the story ends. Nonetheless, there is a lot of really, I think, genuine drama and some nail-biting moments. I remember, I've been very close friends with Alan and a number of the other people on the New Horizons team for many years. And I remember thinking many times, I can't believe what these guys are going through. This is crazy. This is going to make a really good book someday, especially if they succeed. And I literally remember thinking that, you know, even a decade ago, because there were so many twists and turns of this story. And then when a few years ago, New Horizons was actually, after so much happened, which we'll tell you about, approaching Pluto finally, and Alan and I started discussing the possibility of a book. I was just thrilled that I had the opportunity to work with Alan on telling this story, because, you know, he's the ultimate insider in this. There are many people involved. There are 2,500 people worked on this, but Alan was not just the leader of New Horizons, but long before there was a project called New Horizons, there was this gang, this small group of rebel scientists who had what at that point was genuinely a little bit of a crazy idea, or at least an improbable idea, of exploring a part of the solar system and a planet that had never been explored before. And Alan was very much the instigator of that effort, which only after a long period of time and a lot of ups and downs and twists and turns and near disasters and near-death experiences and rebirth, after a lot of that became New Horizons. So we tell you that backstory, and then we tell you the story of New Horizons and ultimately the trip 3 billion miles across the entire solar system in 9 years, culminating in, and I'm going to give you a teaser of what we found, although then I'm going to go back into some history and then we'll come back and end with more of what we found. But this is one of our favorite pictures. And it occurs to me looking at this that it's not only one of our favorite pictures of New Horizons, but it is in fact a new horizon. I mean, this is a planet, a place, as you can see, a place we've become familiar with that was for so long, and before 1930 nobody knew about, and then in all the decades since 1930 when it was discovered, it was a smudgy dot, and that's it. We knew nothing about it, and then in this small moment of discovery, we uncovered scenes like this, and you can see mountains and hazes in the atmosphere and flowing material on the surface, and this is just a teaser, but this was the payoff, but it was a payoff of a long journey that really starts in 1930 with this guy, Clyde Tombaugh, an American hero who you may never have heard of, but we tell his story in the book. Clyde Tombaugh is the discoverer of Pluto, but his story is also very improbable and kind of triumphing against the odds, because he grew up very poor, a farm boy in Kansas during the Depression, hard times on the farm, a lot of work to do. He was fascinated with astronomy, self-taught in the local library, built his own telescopes, ground the glass, dreamed of being an astronomer, but he had no way of imagining how he could ever in a million years afford the money to go to college and actually become a professional astronomer. But in his spare time, night on the farm, when there wasn't too much work to do, he would build his telescopes, and he made sketches of the planet Mars and other objects in the sky. And like sending messages in a bottle with some faint hopes, he mailed off his sketches to different observatories. And that was Clyde's life until one day a letter came back from the Lowell Observatory in Flagstaff, Arizona, and it said, "Dear Mr. Tombaugh, we've seen your sketches of Mars. We're very impressed. We are hiring an assistant astronomer. Would you like a job?" So that changed Clyde's life forever, and it ended up changing all of our lives in the sense that our solar system expanded because Clyde left the farm, got on the train, went to Arizona. He'd never really been out of Kansas before, and started working on this project that they had in mind for him, which was to search for what Percival Lowell, before he died, after he founded the observatory, he called Planet X. Percival Lowell believed there was another planet out there beyond Neptune, and it was Clyde's job to go to the telescope night after night. This is a cold Arizona winter, high on a mountain, no heat in the dome, and night after night taking pictures and developing the film and looking for something moving in just the right way that could reveal a new planet. And months went by, and senior astronomers told him it was futile. He had been hired for this job. It would never work out. He kept going, and after more than a year of this was what Clyde found. Between the night of January 23rd, 1930, and January 29th, this little dot you see jumping from place to place between those nights, that was moving in just the right way. And again, he had been developing film like this for over a year, night after night. He found that, and that he knew it was moving in the right way, that it could be a planet beyond Neptune. He had to go back to the telescope, try it again, and then it checked out. And for a very short while, less than an hour, Clyde Tombaugh was the only person on Earth who knew of the existence of another world. And then he went down the hall and told his observatory director, the guy who had hired him, "I have found your planet X." And then a short while later, they announced it to the world. People suggested names. It was a 10-year-old girl in England, Venetia Burney, who suggested the name Pluto. And she lived to see the exploration of Pluto, which is kind of cool. That was the origin of this story, and it was only 1930. So there are people still alive now who have lived out the entire story of our knowledge of Pluto, from the discovery right here to that picture I just showed you where it's an actual world known to us. This is recent history. And then, of course, that leads in ensuing decades to the origin of the space age. And I'm being told my thing here is that all right, Daniel? Okay. Thank you. That leads, the origin of the space age and the first missions beyond Earth. Of course, Apollo. And Alan and I are of a generation of space scientists. And everybody in our generation of space scientists will tell you, and it's absolutely true, that I remember seeing the Apollo, the astronauts on the moon, Neil and Buzz, step off the lander when I was in the 4th grade. And that blew my mind wide open and set me on the course for the rest of my life. And after that, I was already hooked as a kid, but I vividly followed, and we vividly followed, the first missions to the other planets, including right here, this is Mariner 4, the first mission that flew by Mars and returned pictures successfully. On July 14th, 1965, remember that date, it returned these first pictures of Mars. And as we entered into our childhood, this was what was going on. Humans were first sending spacecraft to the other planets, and it was just an incredibly exciting thing to get swept up in as a kid. And a lot of us we knew that's what we wanted to do, was explore space. And in August 1970, this issue of National Geographic appeared. And a number of us kind of remember this. I remember it from when I was a kid. Alan mentioned it to me during one of our conversations about this book, and I was like, oh yeah, of course. And on the cover, the Voyage to the Planets, and this artist's impression of what Saturn would look like from one of its moons. We didn't know yet. We hadn't been there with a spacecraft. And it described the first missions to the planets that had been conducted in the 60s by the first generation of planetary explorers. I hate these ear mics. They're always sort of falling off. There. All right, don't anybody move. The first missions to the planets it described this the first generation of planetary explorers that had profiles of Carl Sagan and these other people that became our mentors, and were sort of the first generation that ultimately trained us, as we're now training the next generation of scientists. But it described what had happened. We'd already been to Venus and Mars with the first missions, and then it started talking about the outer solar system and these plans for what would happen in the 1970s. And all these missions that hopefully NASA was going to be able to launch to visit Jupiter, Saturn, Uranus, Neptune, and Pluto. And in this issue of National Geographic, they had a chart on one of the pages that showed what was known about all the planets. It had a column for each planet, and it said, what it looks like, and what the gravity's like, and what it's made out of, and the atmospheric surface pressure, and all the stuff that was known. And in the last column, which was Pluto, it had question mark, question mark, question mark, question mark, question mark. It was like, oh, that's the place we know nothing about. But, of course, there was a lot of speculation and lore, and this led to a lot of fun science fiction, a lot of stories. The folklore of Pluto was very rich because it sort of was this unknown planet on the edge of the solar system. So there are all these science fiction stories about Pluto as this outpost to interstellar space, and a lot of sort of fun speculation because nothing was known. It was a blank slate, a tabula rasa. And in that same National Geographic issue, they talked about this idea for a mission that they called the Grand Tour that was going to launch in the 1970s and going to visit Jupiter and Saturn, Uranus, Neptune, and Pluto. That was the plan. And the thing is, it was very fortuitous the way the planets were lined up in the 1970s. It turns out that once about every 200 years, the planets line up in such a way that you can do a journey like this because you can slingshot past Jupiter, use the gravitational kick from Jupiter's gravity to fling you towards Saturn, which then flings you towards Uranus, flings you towards Neptune, and you can visit all the planets all the way out to Pluto if you launch at just the right time to take advantage of the way things are lined up. But if you don't do it, they're not going to line up that way for another 200 years. But it turned out, and this was sort of good news for humanity, right when we developed the capability for space flight, the planets were about to line up that way if we launched something in the 1970s. So this Grand Tour mission turned into the Voyager program. And we talk about Voyager in the book a lot because it's kind of the prelude to New Horizons in a way. Voyager was this incredible journey that launched in 1977 and was the first close flyby of Jupiter, Saturn, Uranus, and Neptune, revealed those planets and all their moons. But even though the Grand Tour could have gone to Pluto, for various reasons, Voyager didn't go to Pluto. Neptune was the last encounter, 1989. A lot of us remember it very well. It was very poignant after all these years from getting to Jupiter in 1979 and traveling through the solar system. This picture is one of the last ones that Voyager took at Neptune, and you can see its little moon Triton off the edge here. They're just crescents because you're looking back towards the sun as Voyager's leaving its last planetary encounter and heading towards interstellar space. And this Triton, this little moon of Neptune, which turns out, interestingly, to be sort of similar to Pluto in a lot of its characteristics, was a really, really fascinating place with geysers and all kinds of weird geology that wasn't expected. And that got a lot of people thinking, is this going to be it? Is Neptune the last first planet we're ever going to visit for the first time? Or could there be something more? And that's really where Alan and his colleagues enter the story, because Alan was just finishing up grad school around this time, 1989, and he and a pretty young gang of scientists in their 20s and 30s, they decided, you know what, Voyager's not going to be it. Our generation's going to do something. We're going to keep going. We want to send a mission to Pluto. And they proposed this to NASA, and at first people at NASA said, sure, that sounds good. Let's do a study. But then they were like, oh, this is going to be easy. But no, it wasn't easy. They ran into a lot of opposition, and the powers that be told them, this is never going to happen. It's too far away. It's too hard. It's not that interesting. Forget it, kids. But they did not take no for an answer. And the trials that they went through, that's the core of a lot that's in the book. Cancellations and presidential administrations changing and having to start over, and there's some heroes and some villains. But to me, this story tells you what it actually takes. People know we explore the planets, but they don't know the years of challenges and ingenuity it takes. And these guys got stymied so many times, they had to try some really clever gambits, some of which didn't work. There was the Russian gambit, where they actually tried, disobeying orders from NASA. Alan flew to Moscow and tried to get the Russians to donate a rocket so that they could do this more cheaply. And it almost worked, and then it didn't. But so there are a lot of sort of tangents along the way, and I think we illuminate what it really takes and how the perseverance of a gang of explorers against obstacles that many times they could have said, that's it, forget it, but they didn't. And I'm going to turn this over in a second to my colleague Alan, who'll tell you more detail about the New Horizons mission. But I want to show you this picture. Alan doesn't like me to show this, I think, because it's sort of embarrassing, maybe a little bit. But I think it's really cute. It's in the book. This is Alan Stern with his first scientific instrument, a microscope. And this is somebody who grew up to lead a team that expanded our knowledge of what worlds in the solar system and in our universe can be. So with that, now I'm going to turn the microphone over to my colleague, Alan Stern.
All right, so they tell me that they're going to turn the volume up over the first couple of seconds. Okay, I am so happy to be here on the Intrepid and to be here with you in New York. You may not know this. First of all, this is the most amazing floating aerospace museum probably in the world. You're sitting beneath the Space Shuttle Enterprise that did all of the approach and landing tests that paved the way for the Space Shuttle program. There are so many exhibits here, you could spend an afternoon. And I will tell you, the very first public talk that I gave after we made the successful flyby of Pluto was here on this ship in late July of 2015, less than 2 weeks after we accomplished the exploration of Pluto. But it's also special because we're in New York, and we have special friends here. First of all, our publication team is here, And so would James and Josh and Carrie just stand up for a minute? These are the people that made this book possible. There's Josh. Where's Carrie? There's James over there. Thank you very much. Anselm Fernandez, where are you? There's Anselm. Anselm was a student at the University of Colorado, helped build one of the experiments on New Horizons. He lives and works here in New York. And then I would be remiss if I didn't say it. Where's Sarah? Where's my daughter? There she is. That's my daughter Sarah, who became a New Yorker. New Horizons was a labor of love for a lot of people. 2,500 men and women worked on it under great odds, and we succeeded. And this book was also a labor of love for David and I. 3 years, countless revisions, and I think a really good story. It's such a pleasure. David's been a colleague and a friend now for 20 years, maybe a little longer. I remember meeting him in 1991 in Providence, Rhode Island, and knowing him ever since and following his life. He is probably the finest writer, planetary scientist in the world. And if you haven't read his other books, like Earth in Human Hands or Venus Revealed or others, you really need to. And I couldn't have picked a better partner to write this book with than David Grinspoon. Now, that said, after he showed this twice, now 3 times, I decided I should get even. Earlier this afternoon, I found a picture of David as a boy, not with his first scientific instrument, but with his first scientific mentor, who was actually Carl Sagan, who he knew as a boy. And I sent that picture to him, and I said, David, if you've got the guts, I'll get the glory. Make it the second slide. Now, he apparently didn't do that. So we have to have a little talk this evening over drinks. Anyway, I'm here to tell you a little bit about New Horizons and this exploration that we did. I'm going backwards. I'm holding this upside down. So let's go the other way. Okay, we got past that. Okay, so it's the early 1990s. David painted this picture. We went to NASA. Actually, I got elected to go to NASA, and I was petrified to go to the head of planetary exploration and to ask Dr. Jeff Briggs if he would fund a study to see how we could go on past the Voyager program and explore the last unfinished business of the first reconnaissance of the solar system. And Jeff was fantastic about it. He said, you know, no one's ever brought that up before. That's a really good idea. And so it seemed like it was too easy, but he put some money aside and he formed a working group, and he asked me to be the chief scientist for that group. I was literally still not yet out of graduate school. But they formed this group. There I am in the middle, a little older than with the telescope, but still pretty baby-faced. And a number of people in this picture actually ended up on New Horizons. They're engineers and scientists and some program manager types. And this was the beginning of a 12-year journey, more or less through the wilderness, to figure out how to raise $1 billion on your own. And a lot of it was like this, Lucy and the football. We would get close, and then Lucy would steal the football. We would get close, and Lucy would steal the football. And sometimes it was understandable but technical. Like once we were just about there, and a Mars mission literally blew up a few days before reaching Mars. And then NASA decided to take the money for Pluto and build another Mars mission to replace the one that was lost. And other times, the people who were managing it, the project, didn't do a very good job, and the price would rise too high, and NASA would, and rightfully so. And then other times, there were bad guys, and David writes about the villains in the story too. And there were some people that really had ulterior motives. And that just makes the story better. It wasn't better living it that way, but it reads really well. Anyway, we got past all that, and this is really what made the difference, because in the end, it came down to the entire National Academy of Sciences. And this is written up in the book, in a shootout in the early 2000s, in which all the ideas for planetary exploration were competing for a budget in which only 1 in 10 could be funded. So you had to really rise to the top. And we did. We ended up being ranked the very #1 priority. And here's why. It wasn't just because of Pluto. It was because of this disk of material that was discovered in the 1990s beyond the orbits of Jupiter, Saturn, Uranus, and Neptune. It's the context for Pluto. It's called the Kuiper belt. It's named after a mid-20th century astronomer who in 1951 postulated it. His name was Gerard Kuiper. But the technology, the 50s, 60s, 70s, 80s, wasn't good enough to find it. In the early 90s, it was discovered. And it's teeming with comets. There are hundreds of thousands of things the size of Manhattan there that are the building blocks of small planets. And there are another dozen small planets like Pluto out there. Pluto is the biggest, the brightest, and thanks to Clyde Tombaugh, the first discovered. 2 generations ahead of his time, because nobody found any of the others until they had 90s technology. That's how good Clyde was. But when we discovered that there was a third zone to the solar system beyond the rocky planets down by the sun and the giant planets, this was a whole new part of the solar system and a whole new class of planet. The priority for studying Pluto, which itself was interesting, rocketed to the top. And so we got a chance to compete. Our team took on the most experienced people in the world, the Jet Propulsion Laboratory at Caltech. We were kind of the David, as this David describes in a David and Goliath battle. And sometimes David wins, and that's what happened. The upstart New Horizons team beat all the seasoned veterans, frankly because we had a better proposal, and we had a better team in the end, and NASA knew it. And in fact, one of the most gratifying things that's happened to David and I since we published this book earlier this week was just today we got an email from the former head of all science missions at NASA back at that time, who had just read the book and congratulated us. And he said, you know, there was only one mistake. You didn't really say how good the New Horizons proposal was. You said it was a close call in the book. It was not a close call. Wes Huntress, who's heavily featured in the book, said, you guys were far and away the best choice. And as a result, we got to build this little spacecraft. And it's a little spacecraft. We have a comparison to Voyager in the book, and we refer to Voyager as a houseboat and New Horizons as a hamster. It's less than 1,000 pounds, and it had to be light because we wanted to cross the solar system fast. And the lighter the spacecraft, the faster the rocket could push it. And this spacecraft contains in it everything needed for the journey. All the guidance systems, the propulsion systems, the onboard computing, the data storage, thermal control. Here's our dish antenna. Here's a nuclear power generator. It looks like a hair curler. I know. It's not a hair curler. Okay, it's a nuclear power generator fueled by plutonium, the element in the periodic table named after the planet Pluto. We sent plutonium to Pluto. That's our little spacecraft. And like Noah's Ark, inside there's 2 of everything. 2 guidance computers, 2 propulsion systems, 2 main computers, 2 sets of transmitters and receivers. This is a little bit more of an engineering drawing in which we've taken off all the gold foil, and you can actually see what the structure of the spacecraft looks like. This antenna is only a little more than 6 feet across. It's pretty small. And there's only a 30-watt transmitter that has to transmit across billions of miles back to the Earth to send the data home and to receive the signals from the Earth. One of the things that we did I thought that was very special was, and sentimental, was that we actually went to the Tombaugh family, because I knew that in the late 1990s, before Clyde died, he had said, if you guys ever get a mission to Pluto, and there's a way to fly ashes to my planet, I would like that done. And it got to be 2005, and New Horizons was complete, and I called up his widow, Patsy, and I said, Patsy, I want to ask you 2 questions. I want to ask you if you have some of Clyde's ashes, we would be honored to fly them back to his planet. And I'd like to invite you and your family to the launch to come and be there, because we're flying to Pluto. And she said yes to both. And she sent the ashes to my office in a little container. The spacecraft engineers built that container to put them in, and actually used it in an engineering way to replace one of the balance weights on the spacecraft. And I wrote a bit of text, and I'll read it to you. And this is on a spacecraft that's leaving our solar system with Clyde's ashes. It says, interned herein are the remains of American Clyde W. Tombaugh, discoverer of Pluto and the solar system's third zone, Adele and Muron's boy, Patricia's husband, Annette and Alden's father, astronomer, teacher, punster, and friend, Clyde W. Tombaugh, and his dates, 1906 to 1997. I think I've read that to 100 audiences, and I almost lose it every time. It's very hard to read those words. Well, the other thing I wanted to tell you is space flight is a team sport. There's no space flight that's ever been done by one person. This is the New Horizons flight team, just a few days after the flyby of Pluto. This picture was taken by Michael Soluri, who might actually be here. He's a Manhattan photographer, one of the finest photographers I know, and he was our project photographer. And I just want to point out, the book Chasing New Horizons is about a team of people. It's not my story, it's our story. And there are dozens of voices, from NASA administrators to individual scientists and flight controllers and engineers, project managers, myself, and others on the team. And I just want to emphasize the team aspect and how brilliantly David wrote the book, so that you hear these voices throughout the book intertwined with the plot lines of an underdog team, an amazing engineering project, great science, and a victory in the end. So here's just the science team, and this is just a few days before we launched the rocket. It had finally been rolled out to the launch pad. New Horizons is here, way up in the nose cone. This launch vehicle is the size of a 25-story building here in Manhattan. This is a big rocket. These solid rocket motors are individually 7 stories high. The whole contraption weighs over 2 million pounds, okay? And it's about to fly supersonically. And we're going to show you that launch on the 19th of January, 2006. So this is the last few seconds of the countdown in the control room in Florida. And this is just before we ignite all 7 engines at the bottom. This is the most powerful vehicle that then existed in the U.S. inventory. And we launched it almost empty. New Horizons is so small, we used to call it the hood ornament on the Atlas V. And look at that downtown building go. It's going vertical. That cloud layer is at 10,000 feet and only took 15 seconds to loft itself 2 miles. 30 seconds after launch, it went supersonic. And you can see through these long-range telephoto lenses the 5 solid rocket motors and the 2 liquid propulsion engines at the center that are all burning to accelerate to 18,000 miles an hour orbital speed. And this rocket did that in 8 minutes flat. Now, the first thing that happens that's interesting visually after launch is that the solid rocket motors run out of fuel. And then they're just empty casings, and we don't want to carry that weight to orbit. So they're going to separate in 2 waves here. First 3 and then 2 more will come off. There we go. And now the vehicle is much lighter and can accelerate even faster on the main engines until they run out of fuel. But already the vehicle is at space altitudes. And so we don't need the nose cone, the aerodynamic fairing that's protecting that little spacecraft from these tremendous wind forces. And so these fairings are ejected so that it's even lighter and can accelerate even faster. And just in the next few seconds, that rocket is going in a cloud, and that was the last that anyone ever saw of New Horizons, that moment. We have never seen it since. We talked to it by radio, but no one's ever had a picture of it. We can't see it anymore. We launched it across the solar system. First stop, Jupiter. 1 year later, 500 million miles away. We did it in 13 months. The previous mission to Jupiter took 4.5 years. The mission before that took 6.5 years. Blinding speed. And then, after using Jupiter for a gravity assist to accelerate us further, and it was the only thing we passed along the way, by the way. And so it was our only chance for a flight test to work out the kinks and the bugs and all the software to be ready for Pluto. Then we traveled for 8 years across 2.5 billion miles of space. It doesn't look big on the board, but we're traveling almost 1 million miles a day, 7 days a week, 52 weeks a year. Most of this time, the spacecraft was in hibernation. It was a technique we developed that let the spacecraft take care of itself and turn off most of its systems to preserve their life against wear and tear. And meanwhile, our little team on the ground, that it shrunk from 2,500 people to just 50. Less people than are here. For all the engineers, all the flight controllers, the project manager, everybody, and the science team, so that we could prepare what we call Battle Plan Pluto. And there's a chapter in Chasing New Horizons by that very name that gives you the inside view of what it's like to plan a one-shot encounter where everything, 26 years of effort, all the political battles, all the engineering and funding challenges, the stress of launch, and the entire journey across our solar system came down to, would it work on one day in July of 2015? And so we tried to make sure that that was a bulletproof piece of software, that we had backup plans, that we had backup training, that we had mission simulations. Battle Plan Pluto goes into all of that. I'm trying to advance the slide, but it seems to be stuck. Let's try again. Can you advance it? Oh, I think almost. Can I do it from here? Yes. Hey, that works. Okay. Who's that lady? Anybody know? You have it right. This is Alice Bowman. She is the Mission Operations Manager, which is an acronym in our business. Every mission has a Mission Operations Manager. They're called a MOM. Whether they're a man or a woman, they're called a MOM. Alice Bowman is the Mission Operations Manager for New Horizons. She's been on the project since 2001 when we started to build it and design it. And she is a hero of New Horizons, as you will see in the book, because the spacecraft had a near-death experience. After 3,300 days of travel, uneventful travel across the solar system, with 10 days to go, the spacecraft went offline. And Alice and her team recovered the spacecraft and put all the flyby plans that had been erased back up on the main computer. And if you've seen the movie Apollo 13, where the engineers are sleeping on desks and eating out of candy machines, it was just like that. I was there. It was 72 hours of round the clock, get it right, or this spacecraft is going to sail by Pluto, and you'll never see anything about it. So let me work this from the monitor. So there's Alice. I want to tell you, it was a very tough navigational challenge to reach Pluto, because we not only had to fly by the planet, but we had to intercept it on a very specific trajectory in order to accomplish the science. We had to fly through Pluto's shadow, and the shadow of its big moon, about the size of Texas. That moon is called Charon. We had to fly through those shadows so that our spectrometers could look back at the sun and watch the sun set through Pluto's atmosphere to determine its composition as a function of altitude. And that in turn meant that we had to arrive and fly through an imaginary window in space that was only 40 by 60 kilometers, or about 30 by 40 miles. That sounds like a pretty big window. You know, it's the size of a big county in upstate New York. But when you're aiming from 3 billion miles away, that's a really tiny target. And somebody did the math. It's the equivalent of hitting a hole-in-one from LA to New York. But it was harder than that. That sounds hard enough. We also had to arrive at just the right time, because the software on board was programmed to look in certain places for each of the moons and to center them in the fields of view. And the spacecraft is very smart in some ways, but it can't actually see what's in the cameras, believe it or not. And so you just point and shoot based upon calculations. And so we had to arrive within plus and minus 9 minutes of the time that we planned at launch, or you would see a half of Pluto or a half of a Charon, or none at all if you're further off. And so I'm proud to tell you that we actually arrived only 86 seconds off target after 9.5 years. And even prouder to say we were 86 seconds early. Some of you, at least a few people here I know, were at the flyby in Maryland at our mission control. Thousands of people came to this. And billions, and I'm not exaggerating, billions watched it around the world. NASA had never seen anything like this in terms of a response, and it's largely because we're in the 21st century and everybody could participate. And the book tells the story of how, you know, it is everything from Big Bang Theory writing New Horizons into the script to Google giving us the Google Doodle for the day. And this amazing response in the press and the media and people responding to this. It was just an incredible experience to be at. And I'm going the wrong way. And when it worked, Alice and I had a little hug. The people who worked on this project, New Horizons, worked on it for 15 years. Our kids grew up. We lived this life of 7 days a week and 52 weeks a year together. I remember the day that we launched. I followed a tradition that is, someone has anonymously sent roses to the mission control team in Houston on launch day of every shuttle mission for 30-something years with a little note, good luck and Godspeed. So, being interested in space history, the morning that we launched New Horizons, I had a dozen roses delivered to mission control in Maryland with a little note saying, I can't imagine any better team to fly across the solar system with. Let's get started. And then I sent another dozen roses on the day we flew by Pluto with another note. And all of that is brought out in the book. So we are really quite a close family. And this is a candid shot taken that morning in the science room at the Johns Hopkins Applied Physics Lab, literally at the moment that the science team was seeing the first close-up of Pluto. And that is not staged. This is genuine emotion from people who had worked on this for huge parts of their career and seeing this actually work. And there were hugs and fist bumps and people were crying and jumping up and down. And it was really something, really something. David's prose really bring this out, what it was like. I want to close this talk by telling you a little bit about what we found. This is a family portrait of Pluto. So this is about the size of the continental United States. Charon, half Pluto's size. It's actually in the foreground, so it looks bigger than half Pluto's size. It's closer to us. And then here are two of the four small satellites. Here are a close-up of the four small satellites. They're called Styx, not named after the band. Nix, Kerberos, and Hydra. And this is their distance from Pluto going outward. And this is Charon for scale, which is about the size of Texas. These guys are made of water ice. We discovered that with the spectrometers on New Horizons. We now know their sizes, their reflectivities. They're as bright as freshly driven snow. And we know their ages from counting the number of craters on them. We can tell how long they've been out in the rain of bombardment. I'm not going to say much more about them because they're not the star of the show. The binary planet, this weird sci-fi pair, Pluto and Charon, they're the stars of the show. We had never been to a binary planet before. That was part of the allure of exploring Pluto. We think binary planets are common across the galaxy, but in all our exploration before, we had not been to something like this. It's interesting, isn't it? Look how different they look. This pair, they say that married couples, they stay together decades and they start to look alike and talk alike. And, this married couple has been together 4 billion years. They don't look anything alike. Pluto is bright and colorful. It's got an atmosphere. There are things that are going on dynamically on its surface. Some of the surface features, like the heart, are brand new geologically. They're just formed yesterday. And Charon's old and battered and beat up and kind of the dullard of the pair. These two have been in the same environment, same temperature, same radiation, same impacts for 4 billion years, and they evolved completely differently. And that's probably telling us that when we visit other planets in the Kuiper belt, if these two could look this different and be in the same place, that we will find as much variety in exploring the Kuiper belt as we find in exploring Venus and Mars and Earth that are all completely different. Here's a close-up of Charon. The entire surface is made of water ice. Every feature you see there, except there are organic residues on the pole that causes the red color, a giant canyon system. And all these craters date the surface to 4 billion years old. Unlike Pluto that produces new terrains all the time, Charon died geologically in the ancient past, shortly after its formation. In fact, it was formed very hot, and as the water ice cooled, we all know what happens when you freeze water ice, it expands. And that actually caused this massive crack running for 1,000 miles, much bigger than the Grand Canyon. As that ice expanded, it created great stresses that created this, what's called an extensional tectonic belt. Now I want to talk about Pluto, the star of the show. This is a close-up made of New Horizons images in color. Now the color's been exaggerated here so that you can see the subtle features more clearly. This is, you see up there in the green box, the western, north is up. This is the western lobe of the big heart on Pluto. This is a glacier with 1 million square kilometers. We didn't expect this. I have a bunch of great geologists, planetary geologists. Not a single glaciologist was on the team until after flyby, when I quickly hired a couple of good ones. This glacier is surrounded by mountain ranges that tower more than 15,000 feet. The mountain ranges are made of water ice, and they're coated with a frosting of frozen nitrogen, which is what this deep glacial deposit is made of. And then you can see big tectonic fissures, old battered terrains, not a single crater on the surface of Sputnik. It's brand new. And we have no idea how Pluto does that. And the mountain ranges on Pluto, which are as big as the Rockies where I live in Colorado, have this enchanting beauty. They're snow caps. Snow caps in the Kuiper belt. But this bright snow on the tops of these mountains is not water ice. We fingerprinted it with our spectrometers. It's natural gas. It's frozen methane. Don't light a match. Fortunately, Pluto has no oxygen in the atmosphere. So even if you tried to light a match, it wouldn't work. But it's just amazing. Snow caps. We have only seen snow caps on 2 other planets, Earth and Mars. This is one of my favorite pictures. It was taken 15 minutes after we flew by. Looking back, the sunlight is filtering through Pluto's atmosphere, and you can see the haze layers. These stretch up hundreds of miles into the sky. And you can see how rugged the terrains are. It's smooth on the glacier, but very rugged in the mountain ranges. It is really a planet that's geologically alive, and no one expected that, because we thought, being a small planet, it should cool off, like Charon did. But somehow, Pluto defied all of our expectations, despite all the textbooks. You know, what I like to say is, apparently Pluto can't read those textbooks, because it doesn't care what all the geophysicists said. And it's teaching us brand new lessons. I'm going to close with this picture, which is a true color picture of Pluto's atmosphere. I love this picture, and I'll tell you why. It's not the most scientifically compelling. Doesn't have the most information in it. But let me tell you how this picture was taken. After we flew past Pluto, we looked back on Pluto. The sunlight is filtering through its atmosphere. Pluto is backlit by the sun. If you're standing close like me, you can see mountains on the perimeter, but I don't think you can see that from where you are. But this is the most important picture we took from my perspective. I worked on this, like a lot of other people, for decades. We took career risks, and we succeeded. And this is the we did it picture, because you can only get this picture by being on the far side of Pluto. And we really did it. And thank you very much. David, come on back up here. There you go.
All right, thanks. Alan, don't go far, because I'm just going to say a couple concluding things, and then Alan and I are going to sit up here and take your questions and have some discussion with you. But I did want to point out another aspect of this amazing journey and the encounter was the incredible public reaction to this. And the involvement of the public surfaces a few times in the story of Chasing New Horizons, because during a couple of the times when the mission almost didn't happen because NASA canceled it or the Bush administration canceled it, the public rallied behind Pluto. There's something about Pluto that kids love and people love, and literally one time when the mission was canceled, tens of thousands of letters came into NASA headquarters. NASA was hounded by a public outcry that people wanted to explore Pluto. And then when the encounter itself came, the reaction was overwhelming. I mean, NASA has public communication specialists. They prepare for reaction. They've done Mars landings, and they think they know what to expect. But they were just blown away with the interest online and in person, the thousands of people that showed up to want to participate in the encounter. And the media responded in a wonderful way too. During the mission, the planning of the mission, Alan and his colleagues used to talk about taking the New York Times picture, one of the first pictures they wanted to be sure in return, because they knew there was going to be press. And this is kind of fun. Here's the cover of the New York Times on July 15th, on the left, July 15th, 2015, the day after the Pluto flyby. And you remember when I mentioned Mariner 4? This picture, this New York Times cover is 50 years to the day after this New York Times cover from July 15th, 1965, which was a picture of the first pictures of Mars from the first planetary flyby that was successful. So these 50 years, that caps this journey we've gone in what Carl Sagan called the preliminary reconnaissance of the solar system. And part of what's incredible about New Horizons is that it was the capstone to that first era when we first uncovered the planets. And that public outcry, the way the public reaction, the way it unfolded, was very much a hallmark of the first 21st century first planetary encounter, because people went crazy online. And there was this sense of participation that was impossible during Voyager. I was at Voyager as a student at the Voyager Encounters, a very impactful experience. But there was an elitist, an inescapable elitist aspect of Voyager, because you had to be in the room. There was no internet. And then people got to see it the next day in the newspaper. But you know, only the team saw the pictures for a long, long time. With New Horizons, they released the pictures instantly, and it was out there on Twitter and Instagram all around the world. And there was this sense of global participation, that we were all there on the spacecraft, humanity expanding our knowledge of the solar system together. And there was this wonderful outburst of creativity, all these memes that were created, some of them very playful, and just all this clever response to Pluto, you know, that continues. And there was something gratifying about that, just the way people responded with the creativity that just extended around the world. So, you know, I think we're still digesting scientifically what this mission means, and you know, that just the outpouring of public interest, and the fact that New Horizons isn't quite finished, because this coming New Year's Eve, it's going to encounter another world at the fringes of the solar system, and we're already seeing a lot of public interest in that. And then, after that, New Horizons will leave the solar system. It's only the 5th human-built craft that was launched from Earth with enough speed so that it is going to escape the sun's gravity. It's going to be the number 5, the 5th relic of our civilization that will leave the sun's influence. It will wander the galaxy. It will literally last forever. It will outlast not just human civilization, it will outlast the planet Earth. And so, in addition to expanding our knowledge of what worlds can be in the solar system, and marking this historical time as the time when we finished the initial exploration of our solar system with the New Horizons spacecraft, it is also something that is a piece of our civilization that will literally live forever. And with that, I want to bring Alan Stern back up here, and we'd be very happy to entertain your questions, and then a little later we're going to sign books. So thank you.
Okay, so we have 2 microphones. If you have a question, please raise your hand.
Books are going to be on sale. I have to say, David wrote a great read. I'll tell one funny story about this. We turned the book into our publisher last July. And about a month later, James and his boss called us up and said, "This is a great story. You wrote 600 pages. No one will read it. And you have to cut it down and make it flow a little faster." So it is a pretty fast read now. And still, we kept all the main elements of the story.
We kept the really good stuff.
Yeah, yeah. They ought to make a movie. Okay, so question time.
We have our first question over on your left.
Hi, Alan and David. I have 2 questions, one small one, one big one. So you referred to Pluto and Charon as a binary system, but we know that it has more than one moon. Is it because of the relative masses? And the other question I had is, you said that both of you were inspired by earlier missions in your path in life, and we know that the New Horizons mission has inspired so many people. What is NASA's strategy to making sure that those new group of people is finds ways in order to express their interest in space exploration? Or are we just going to leave it to private space corporations to handle that?
You want to take the first or the second?
Either one. Just shoot for. Well, you know, as far as your second question about the role of private space exploration, NASA, you know, isn't going anywhere. And in fact, people at NASA are really psyched. I mean, I know, you know, Alan and I know a lot of people in the space exploration business. We don't know anybody at NASA who's saying, "Oh no, you know, Jeff Bezos and all these other private space companies, SpaceX, like they're going to take our business away." No, it's NASA this way can focus on doing other things. They don't have to be the bus service that launches stuff into orbit. The technology's gotten to the point now where there's a role for private companies. And so, if anything, that frees up NASA to put its resources into science and other more specialized things that are really what NASA does well. So we actually are pretty bullish on this public-private partnership as a major new thrust that's going to help us do more in space.
Yeah, and I actually think that it's inspiring that we now have companies in the United States that can do what formerly only entire nations could do through their space programs. And we're the only country on Earth that is doing this. We're really leading the way to Star Trek, I think. Now, thank you. I want to say something about your scientific question. So Pluto Charon is a binary because their mass ratio is so comparable and they're so close that the gravitational balance point is between the two, just like in a binary star. And the binary is surrounded by the 4 small satellites that orbit the pair. I hope that answers your question. If it doesn't, we can talk about it afterwards.
And the other point, just real quick, you asked about the young people getting involved. I mean, one of the things I love about this story is there's this generational aspect to it because it takes so long to get a mission to Pluto. So just as we were inspired by the sort of first generation of space explorers, and now our generation's getting a chance to do some things like New Horizons, there's also this cadre of younger scientists who are being trained now on New Horizons and other missions by our generation, and who we fully expect are going to just keep doing amazing things in this coming century. So part of the process of science is this sort of mentorship that we benefited from, and hopefully we're doing a good job of carrying that on into the next generation of explorers.
Okay, who's next?
All right, we've got another question right up here. Do you still have a question,
go.
sir? Oh, never mind. Do we have one right over here?
Yes, sir.
I'm looking forward to hearing about the New Year's Eve approach to the Kuiper belt object that you were talking about. Is there any prospective opportunity for additional objects to be surveyed, and in a longer time scale, how long do you expect the spacecraft to remain active?
Okay, that's 4 questions. Let's see if I can remember them. So first of all, it's background. After the data download from Pluto and finished in late 2016, we redirected New Horizons. It was approved for a 5-year extended mission to keep exploring in the Kuiper belt. 5 years, like that Star Trek Enterprise thing. 5-year journey, and we are now flying to make another flyby 1 billion miles further out, New Year's Eve and New Year's Day this coming year. And after that, we have fuel and power to run the spacecraft for 20 years. And once we get through that flyby, we will decide what other targets we might be able to reach, or other science we can do with the telescopes and other instruments that are on board, acting as an observatory in the Kuiper belt.
We've got another question right over here.
Yeah.
How long did it take to get the first images back to you from when the flyby happened in 2015?
Yeah, so the question is, how long did it take for the images? There's 2 answers to that, 2 parts of that answer. So when you send a signal from New Horizons by radio at Pluto back to Earth, it's traveling at the speed of light, which radio waves travel at. And at that distance, it's 4.5 hours. If you have 1 bit in a data stream, it'll take 4.5 hours to make the crossing that New Horizons took 9.5 years to do. But in each image, there are tens of millions of 1s and 0s. And so it actually takes us several hours at our data rates to assemble 1 image on the ground, right? A long bit train that's sent from the spacecraft and received in football field size antennas on the Earth. And we took literally 5,000 times as much data as the first mission to Mars. It took us 1 year and 3 months to get it all back to the Earth. Great question.
I saw Neil deGrasse Tyson speak, and he was addressing the controversy of the downgrade to dwarf planet. And this obviously happened as New Horizons was already on its way to Pluto. Did that impact any of you from a planetary scientist standpoint?
Pissed us off. And we took a vote, and I don't know if you heard about that in the press, but Neil is now a dwarf astronomer. And I can say that Neil and I went to graduate school together. He was a skinny kid with a fro, and when I met him, he was 21 years old. So he could push us around, we could push back. Here's the real story. There are different specialties in every field. In law, there are real estate attorneys and there are divorce attorneys and many more specialties. And in medicine, you have cardiologists and endocrinologists and neurologists and podiatrists. They're all different, even though they're all doctors. In the space field, we have many different professions. And one is astronomers. They study stars and galaxies. The other are people like David and I that specialize in study of planets. They're very different expertise, just as different as, say, real estate law and divorce law. And you wouldn't ask the one for the advice on the other, vice versa. God forbid if you ever had a neurological problem, I doubt you'd go to a podiatrist, right? A foot doctor. So don't go to an astronomer, seriously, to learn about planets, okay? Because they're not expert, any more than I'm an expert in black holes, right? And the astronomers literally panicked when we started discovering a lot of planets and literally freaked out that school children would somehow not be able to remember all their names if there were lots of them. And so, forgetting that there are lots of rivers on the Earth, no one has to memorize all their names, lots of mountains, that there are 114 elements in the periodic table, and nobody said there should only be 8. Right? There are 50 states, and no one says you can't remember the names, let's go back to 8 states. Right? They just legislated. They found this crazy definition that would make it work to keep the numbers small. That's a very anti-scientific way. It's like saying I'm rejecting the data, and I'm going to form a theory that encompasses my worldview. The priority is keep the numbers small.
Yeah, and unfortunately, they came up with a very kind of nonsensical criteria. So they define planet in such a way that it has nothing to do with the actual properties of the object. They're saying it is or is not a planet based on what else is orbiting around it. And it creates a lot of sort of silly paradoxes, like according to that definition, the Earth would no longer be a planet if you moved it out into the asteroid belt, for instance. So it just doesn't make a lot of sense to us. And in fact, planetary scientists kind of often ignore that. And when we go to meetings, we talk about Pluto as a planet. And, unfortunately, the press kind of ate it up because they said, oh, the IAU, the International Astronomical Union, they're the authorities. But we don't actually consider them the authorities. They do a lot of good work, but not on that particular topic. So we consider Pluto to be a planet. And especially when New Horizons, what's that on that cover of the book? That's a planet. Next question.
All right.
We have one right over here.
Dude. Yes, next.
Yeah, back here. Considering, you said that the atmosphere of Pluto was hundreds of miles up, and considering for gravity and density of the gas, is the atmosphere of Pluto longer than Earth? Is there actually more gas surrounding it than Earth?
Okay, great question. So the atmosphere of Pluto shares something in common with Earth. Both atmospheres are mostly made of nitrogen. Our atmosphere, is 21% oxygen and 77% nitrogen, a couple percent everything else. Pluto's atmosphere isn't 77% nitrogen, it's 90-something% nitrogen. Now, the thing is, Pluto being smaller has lower gravity. And as a result, the atmosphere is not held as tightly, so it's puffier. And that causes it to be taller, but there's not actually as much of it, by a long shot, by orders of magnitude. Pluto's atmosphere is like the Earth's very upper atmosphere. And so there's only a small amount of mass compared to our atmosphere, but its altitude extent is greater. Good question.
We actually have a question coming from one of our online viewers.
Mm-hmm.
So we've got a question from Twitch chat here. I'm back here with the camera. So we know how important mass is whenever you design this probe because you need the very high speed to get there in a reasonable amount of time. Is there anything you had to take off of New Horizons that you might want to maybe put on the next mission to Pluto?
Actually not. We originally proposed to fly 7 scientific instruments with tremendous scientific firepower, and when we got it all built, we were on target for mass, and we flew all 7. When we go back with an orbiter, because we're going to be there to stay, we're going to want to bring new kinds of instrumentation, like mass spectrometers that can literally taste the atmosphere, determine its detailed composition, and radars that can penetrate through the ice to the base to tell us if there's liquid below. and thermal mappers and other things that we normally put on the second generation missions, like orbiters, instead of the quick flybys. But we're very happy with the instruments that we flew on New Horizons. And frankly, if we were going back, let's say, to make new flybys of other dwarf planets, the payload that we flew on New Horizons is pretty much perfect for that kind of first reconnaissance. I wouldn't change anything.
We have time for 2 more questions. First one's right here.
A question about sending the data back from the ship. So you're saying the satellites on Earth are the size of football fields. Does this work as line of sight? Are you only able to capture data when the Earth is facing the right direction? Then you have to wait for 24 hours until it comes back?
There's something really cool that we describe in the book that I think everybody should know about, because it's a wonderful thing that humans have built on Earth. It's called the Deep Space Network. And there are 3 ground stations, a giant antenna, one in California, one outside of Madrid, Spain, and one in Australia. And with those 3, as the Earth turns, any spacecraft out in deep space is always in direct line of sight with at least one of them. And they hand the signal off one to the other as the Earth turns. So with that deep space network, one of those football field-sized antennas is always in the right place so the spacecraft can talk to us.
All right, we've got our last question right over here. Oh, yes. Hi, thank you so much. So you were talking about how the spacecraft will live forever. Did you ever consider putting something on it, so not weight-wise, but just description-wise, if it ever got in contact with any extraterrestrial force?
Yeah, we did.
Call this number.
But we didn't. Now, here's the story. The Voyagers and Pioneers, the 4 spacecraft before us that are leaving the solar system, all have, the 2 Pioneers have like a physical plaque. It's 70s technology. And the Voyagers with late 70s technology had CD-ROMs on them.
No, they had a record.
They had a record, that's right. You're right, it wasn't even a CD.
An actual phonograph record made of gold.
Yeah. In any case, they have messages for if they're ever found. And there's a chapter in the book called Alligators in the Water about how many problems we were facing to build this on time and at very low cost, and there were lots of engineering challenges. And some people on the mission really wanted to do this thing, but we knew the story that over time, as things became more politically correct and more politically sensitive, that choosing what goes on those messages and having all the kinds of balance and all the committees that would get involved and so forth, I thought would be a huge distraction, and we need to keep our eye on the ball to go explore Pluto. And so I'm the bad guy that said no. We are not going to do that. Despite how much fun it might be, we need to keep our eye on the ball. So we didn't. However, we have a plan. And we expect to do this plan after a few more years. We're going to have a contest for people on Earth to choose things that we will radio up to the spacecraft and store in the memory on board digitally. Very 21st century way, right? We're going to upload images and text and other things. And in fact,
Music, maybe some music.
But we have a small enough memory that it's going to be very selective. So what we hope to do, and I don't know that we'll be able to do it, is to find a museum, maybe like the Air and Space Museum, that will archive everything that everybody nominates for what the people of Earth in the early 2020s wanted to put on New Horizons. We will only filter out things that are insulting or obscene and somebody plays a prank on us or something. But everything will go in that archive on Earth. A tiny fraction will actually be on New Horizons, flying out into the universe. That's our plan.
Thank you so much. Okay, so we have books for sale over there on the other side of the pavilion. So please help yourself.